All right, so today we're going to be working on examples that use sigma notation. So sigma. Sigma looks like a big, backwards, crazy looking E. It's, again, called sigma. And this whole thing is we're going to be expanding out using sigma. Now, sigma, all its job is to do addition or add. Okay, so that's what sigma does. So in an example, we're going to use sigma, and then you're going to see how you'll see the addition sign in what we do, and then some other things that we're going to be working on. And there's more to this anatomy of sigma. And let me just write that out one more time. So usually they use a letter, we'll say N, and we're going to start off at some starting point. Let's just say, we'll just make, for example, we'll just say it starts at 1 and goes to 3. That means is whatever is going on here, which I'll explain in the next problem, we're going to start off with 1 and we're going to go to 2, then we're going to go to 3, and we're going to stop at 3 because it says stop at 3. So again, so to be a little clearer, let's just do an example and you'll see how this all works. All right, so we got sigma from, let's say, we're going to go from 5 to 10, and our expression we're going to use is 20 minus n. Okay, so what are we going to do? All right, so the bottom number, again, here, tells us where to start, and we're going to plug in that number into the expression. So let's see if I can do this a little color-coded here. 1 minus, and we're going to put the 5 in here. Then we're going to add. So that's where the add comes into play, what the sigma is doing. And we're going to do 20 minus, now, what's 1 more than 5? 6. Then we're going to add again, 20 minus 7 plus 20 minus 8 plus 20 minus 9 plus 20 minus 10. Now, when do we stop? Well, we stop when we reach the number on the top of our sigma. So it said it stops at 10, so that's where we're going to stop. Now, if you notice, I have to do all this math and I have to add all this up. So I'm just going to write right above it what each one of these things is. So this is going to be a 15. This is going to be 14. This one's going to be, amazingly enough, 13, 12, 11, and 10. All right, so again, I just did all those subtractions, and now I'm going to do is add up all these numbers. So use a calculator, use your mental abilities, whatever, and I believe if you add all these up, you will get 75. So to answer the question of this sigma notation, when n goes from 5 to 10 to 20 minus n is 75. One thing I wanted to add too is sometimes you'll be asked the question, how many terms will be created using this particular sigma notation. So a term is what we get when we do our little maths in here. So that 15 is a term, that 14 is a term, that 13 is a term, and so on. So if you count those green numbers, we've got 1, 2, 3, 4, 5, 6. We have 6 numbers, 6 of those green numbers. So there are 6 terms. Now, how can we come up with that number without having to write this all out? If the question were to ask you how many terms will the sigma notation generate, how do you figure that out? So the way you figure it out is you take your number on the top, which is 10, you subtract the number on the bottom, okay, and then add 1. So when you do that, 10 minus 5 is 5, plus 1 is 6. So you'll get 6 terms. It's sort of like page numbers. If somebody asked you how many pages you've read, you subtract the page you're on from the page you started, and add 1, and that's how many pages you've read. So that's how that works. So we're going to do another example. Okay, let's beef up these examples a little bit. So we're going to start, let's do our sigma. Oops, I don't want to use green. Well, that's okay. We'll use green. All right, so we're going to go from k equals 1 to 4, and our expression is going to be 5k squared plus 3. So pause the video if you need to, so you can write it down in case you want to go through the steps with me. And again, at any time you want to just pause the video, try to do the step, and then watch me do it. That works also. So let me go back to black so I can figure this out. All right, so again, I'm plugging in. Again, I'm starting with the number 1, and I'm going to the number 4. So I do 5 times 1, 1 squared plus 3 plus, again, that comes from the sigma, 5 times 2 squared plus 3 plus, again, I'm circling the pluses, the addition signs that I'm using for sigma. The plus, the other addition signs you see are from the expression from in the 5k squared plus 3. All right, so let's do 5. This needs to be 3 now. And then the last one, 4. Wow, I'm trying to write with the stylus. Sometimes it's going to be fun. All right, so now again, if you notice, oops, got my plus sign in there that I'm circling. All right, so again, how am I going to figure out how many terms I have? Well, I could count them, but again, I could do 4 minus 1 plus 1. So 4 minus 1 is 3, 3 plus 1 is 4. So there are 4 terms. All right, so if we do this math, let's use red this time. Okay, so we have 1 squared, which is 1, times 5, which is 5, plus 3. So this is 8. 2 squared, which is 4. 4 times 5 is 20, plus 3. 23. Okay, and again, we're going to add as we go. Plus 5 times, all right, so 3 squared is 9. 9 times 5 plus 3. That's 48. Okay, and then we're adding again. 4 times 2 is 16 times 5 plus 3. So that's what? 80, 83. Okay, so we're going to add up all of those numbers. So 8 plus 23 plus 48 plus 83. And if you notice, look how many red numbers I have here. That are final things. So let me just circle those. Okay, so we got a 48, we got an 83, we got a 23, we got an 8. 4 terms like we said we were supposed to get. Now if we add up all of those, you get 162. And that's your final answer.